talking about today, Josh?
Let's start with hey, Spray-Lock Nation. Thank you for tuning in to another video. This is Brent and Josh here. He's Brent, I'm Josh. Unless we want to change it up, in which case we'd just be confused. But
we could refer to ourselves in third person. That would be fun.
You want to go by the Brent, and I'll go by the Josh? I mean,
Brent says NT-492 is a good...
Please, no.
Okay.
We're not playing Brent Says today.
Okay.
We're in Studio 492. Why?
Because we're talking about NT or Nord Test 492 today. It's from Scandinavia. It's a really cool test. It is a way to
quickly assess concrete's capacity for conducting chlorides.
There you go.
And we're not talking about the band conducting, we're talking about moving it through.
Yeah, so if you don't have time to perform the ASTM 1556 ponding test to calculate an apparent chloride diffusion rate, what you can do is take this little test from Scandinavia called NT or Nord Test 492, and there is an AASHTO standard as well, I believe, that is very similar, where you can take a 50 millimeter thick by 100 millimeter diameter disc of concrete, or
2 inches to 4 inches for you American folk.
Yeah, there you go. And you introduce one side to 10% sodium chloride solution and the other side to a 3% sodium hydroxide solution.
Now, how do you do that?
You say, NT-492 sample?
We're not doing the introduction. You know what I mean. So, for those who don't know, who've never ran the test, how do you keep those solutions from actually not meeting each other?
Yeah, great.
And stay on each side of the...
Yeah, you don't want them to mix because then it's not pretty. But what you can do, it's not dangerous or anything, it's just ugly. So,
I was about to say, great, you just now told me it's a whoosh kaboom.
Yeah, it's not. But what it will mess your test up and you won't get a good number to play with. So the way that we like to do it is the way that's detailed in the standard itself, which is to have a reservoir of the salt solution, the sodium chloride. And in that reservoir, we insert a tube. And this is where Fred's going to put a picture in probably. We insert a tube or a sleeve.
Oh, he's delaying this one. You know that, right?
Oh, I know, like you did last time. With the concrete around the sleeve, it's gasketed, so you can't, have material moving one way or the other. But you put that into your sodium chloride solution, which is going to contact the face of the concrete. Okay. We then put the sodium hydroxide solution inside that waterproof sleeve.
Because we didn't have the concrete come all the way to the top of the sleeves, therefore we have a reservoir on the top.
Yes.
That's important for them to know.
It is. And once you have that reservoir, then you can insert electrodes into both, and the standard will give you, or test method I should say, will give you the indicator of which should be the positive and which should be the negative electrodes. And then using a variable voltage power supply, you introduce a voltage to the sample, and then it forces chlorides into the concrete.
And you get a scream, "It's alive! It's alive!"
Exactly. Exactly. Hopefully not.
No, really you don't. But
hopefully it's going to be a very boring test and you won't have many chlorides moving through the concrete at all.
No, don't say boring tests are fun.
Oh, they are.
Don't make it act like it's boring. That's what we love to do. I enjoy these things.
Yes, but you don't want to watch this test.
No, it's 24 hours long.
Yeah, it can be longer, but the way we like to perform it is we prefer to use a set voltage for untreated versus treated concrete and for a fixed amount of time so that we get a comparison between untreated and treated concrete. There are some other ways that you could perform the test, but for us that helps describe what's going on.
So now after 24 hours, we're pulling it out.
Yep.
Then what are we doing with the sample?
So we pull the sample out and then we cut it, lay it open.
Lengthwise? Or?
No, so this is kind of hard to explain. So if you take the disc and you throw that duct tape to me, Fred, please. All right.
You can't duck it.
All right, so imagine this is a concrete disc. And imagine this is the 2-inch or 50 millimeter dimension, and this diameter is the 4-inch dimension. So when you cut it this way, and you lay the sample open. So you can then add
You cut it lengthwise.
Is that what, with that all that trouble, and I could have just said lengthwise?
Yeah.
Okay.
Or height, I don't care, but yes.
Oh, well. Okay, well, I've never been one for brevity.
No.
So you lay it open and apply a silver nitrate solution to the surface. And when you do that, it precipitates the chlorides out. In other words, it makes them show up. And then
it's like magic.
It is.
It's a little magic show.
That's the one thing about this test
See,
that's
I
a lot of
told you
fun.
it's not boring. We got a magic show here. We make stuff just appear out of nowhere.
You take 7 measurements.
Yes.
You ignore the end 10 millimeters on each side. You take 7 measurements, average them, and that gives you a depth of chloride penetration for the test. And from that, you can calculate something known as non-steady state chloride migration coefficient. That's a big mouthful, but really it all boils down to comparing one concrete to another and how much capacity it has for allowing chlorides into it.
And why is that important?
That is important because of durability, because chlorides impact reinforcing steel negatively. They cause the reinforcing steel to rust and all that. So, but it also happens to be that chlorides are a good tracer.
Yeah.
So it's it can be an indicator of permeability. Yeah. So great question, Josh. I really enjoyed talking about this today, and I hope you enjoyed it.
I think we did pretty good on the timing on this one. We might have kept this one down low.
Yeah, less than 15 minutes. Why don't you wrap us up?
Like Bo and
however you'd like to wrap us up.
Thank you for watching another video here at Spray Like Concrete Protection. We appreciate your time and your energy to take time out of your busy day, honestly, and to watch us, bring us into your office and your homes. We really do appreciate it. So like, subscribe, and we'll be bringing more videos on concrete, and sometimes we even use the SCP products on where you can do those at from a concrete durability side. But I think next time we might actually talk about compressive strength,
flexural strength
and maturity method.
Sure. Can we throw tensile strength in there too, just to talk about it for a minute?
If we're around Christmas time, we put tents on a tree, right?
It might be. All right. Thank you so much, everybody. Have a great rest of your day.
Thank you.